Regular expressions are actually sort of like a mini language that describes patterns. And in fact, regular expressions can be used in many different situations, such as a lot of Unix tools will use them, and lots of programming languages have structures built in where you can use regular expressions. They're very useful for processing strings, doing matching and searching, and things like that. And we'll see that there are certain built-in structures for them in Java in the JAVA.UTIL regex package, and they're used in a few built-in places in Java as well. So as I said, regular expressions are a way of describing patterns in strings, in text data, and they're meant to be concise so that we don't have to, say, enumerate all of the possibilities of how something could match, and we have shorthands for some commonly used things, rather than writing in-depth code that would do the kind of matching that we want to do here. So here's an example of a regular expression. It would match words that start with an A, followed by A or BA, any number of times, meaning that it could be A's or BA's repeated however many times. And in fact, it could be a mixture of A's and BA's, because it could be either of these repeated any number of times. So we can match with either over and over. And then B, at least one time, possibly more. So the star means any number of times, and the plus means one or more times. Here are some examples of things that would match this regular expression. AB, because that would match the A here. No times is still a match for any number of times of the A and BA. And then at least one B matches right there. The same for ABB, AABB, and so on here. And we can see an example here where there's an AB, AB repeated, and an example here where there's an A and then an AB, and then all the rest would match with the B plus there. But the B alone does not match because the A here is not optional. It must be present to match the pattern. The centerpiece here with the star is optional because it could be 0 or more times. And ABA would not match because, again, the B here at the end is not optional. It must be at least one time, maybe more. And then the same over here, ABBA would not match for multiple reasons, one being that B can't be the second character. BB can't be the second sequence of characters because it must either be an A or a BA or a B that finishes us off as a sequence of Bs. And it doesn't end in a B. This one must end in at least one B. So this is a bit of a silly pattern, but we can match with lots of different things. Regular expressions are useful in handling user input. They're useful in searching a file for something that you're looking for. They're also useful in things like matching pieces of DNA. When we do bioinformatics kind of work, DNA can be represented as the A's, C's, T's, etc., and we can match those up to find when two organisms have the same sequence of portions of their DNA. So we can test that a string fits a particular pattern by calling matcher.matches. We can search a string using matcher.find. We can extract substrings from a string using what are called groups. That's where we put parentheses around things. We can replace substrings using a regular expression. So find the thing that has a number in it and replace that number with something. And we can split a string using regular expressions. And we'll see some more examples of all of these. Here is some of the syntax for a regular expression pattern. You can use ordinary characters like A, B, or C, capital A, etc., the number 1, any of those standard characters you're able to use. Some of them are used as special characters, so you'll have to escape them, like /n/x, the same as you have to in Java strings sometimes. You can group things together by putting them in parentheses. You can also do the choice kind of things like we had before, where it could be A or BA, I believe it was. Using the OR bar inside of parentheses, you can form a grouping that is allowed a choice, one or the other of these. You can indicate the beginning of a line or the end of a line. The dot character is used to say this could be any character, but it's only one if it's on its own. So for instance, if I was looking for something that has a capital A and then any other character to match things like as or an or at, then we could do that. It would be capital A dot, and the dot would represent exactly one character. There are also some things that allow you to say how many times something is repeated. There are single characters that let you do that. Question mark allows 0 or 1 repeats of something, so it may not be there at all, but if it's there, it can only be there one time. Star allows 0 or more, as we saw above, or in the previous slide. So if I say C star, that would match to nothing, because nothing has no C's. It would also match to C or CC or any number of C's beyond the 0 that it could match as well. The plus, however, says it has to be there at least once, but it may be there more times. These you will commonly see matched paired with the dot. So you will see things like dot star, which is anything repeated any number of times. That would match to any string whatsoever, including the empty string. Dot star would. Dot plus would mean we have at least one character, could be any character, and it could be repeated any number of times. These are very helpful as sort of fillers, where you're saying I'm looking for the word the, and then anything and a period for the end of the sentence, or a question mark. And so it's a question that starts with the word the, that kind of thing. You would have to escape the question mark because it's a special character. You would also have to escape the period because it's a special character in regular expressions. So you would have to do /period if you want to match to an actual character period, and /question mark if you wanted to match to an actual character question mark. You can also specify the number of repeats inside brackets because, for instance, this system doesn't allow you to say, I would like between 3 and 5 repetitions of something. You're able to do that with brackets. And the same for between 3 and infinity, or exactly 3 repeats. We can specify numbers of repetition a little more precisely using these bracketed repetitions. You can create categories of characters and say, this represents A, B, or C. It will mean one A, B, or C, unless you put a star or a plus or something like that after it. It will mean one of A, B, or C. And then you could say also not inside of the square brackets. This upper, or this pointing up little caret here means not. So this would mean not A, B, or C. You can do ranges, 1 to 9, A to Z, 3 to 5, etc. And so these can be useful for matching things like if you were looking for phone numbers, you could say that it will have 1 to 9 a certain number of times, then maybe a dash, then 1 to 9, and then 0 to 9 internally, and different things like that to make the rules to match to a phone number. And then similarly, you can say not that range. So if it's not A through Z, then we would match to it. So these are some of the syntax. You can find plenty more syntax of how you can build regular expressions in lots of resources online. The Java APIs for Java.UTIL regex pattern will show you some too. Here are some examples. The first example says one of any character and then 0 or more of any character. This is not a particularly meaningful regular expression, but it is saying we have at least one and then 0 or more. This is actually equivalent to saying dot plus, because remember the plus means at least one or more. 0 through 9 plus would capture any sequence of digits 0 through 9. So it would capture just the number 1 or the number 5 on its own. It would capture the number 536 because it can be any of 0 or 9 any number of times. So it doesn't matter. It doesn't have to be the same number repeated over and over. We do have ways that we can specify it needs to be the same thing repeated over and over. But in this case, when I give a category, I'm saying it could be any of these. Look for as many of anything that fits these categories as you can find. So here is any letter or underscore at least once. And then here is any letter or underscore or 0 through 9 as 0 more times. So this would be a good one to match for Java variable or generic names, that they're allowed to be letters or underscores to start with, and then they're allowed to be letters or underscores or numbers after that. You can't start with a number, so the first grouping doesn't include numbers. This is saying the beginning of the line and the end of the line right after each other. And we've got multiple other examples through here. Let's see what ones are actually interesting. This is not space 0 or more times, followed by space 0 or more times, and an equal sign, and then space 0 or more times, and anything 0 or more times. This could be a useful one for finding variable assignments, assignments of values to variables in a Java program. Here we have the start of a line, 3 characters, any 3 characters, and the end of the line. So it would find us any line that has 3 characters on it. Now this one down here at the bottom is perhaps a little bit of an interesting example. So it matches us anything that's 0 through 9, 1 to 3 times, and then an actual period, 0 through 9, 1 to 3 times, and then it repeats that sequence exactly 3 times, and then it matches us with a colon and 0 through 9, 1 or more times. And this whole last piece is optional. What this would match us to is IP version 4 addresses. We can have things like 192.168. etc., etc., and then a port number, colon, and then some port number, like 8080, there at the end, but the port number, as is often the case in IP address, or when we're using an IP address to communicate with something, the port number is optional. There may be some default port that we don't have to define it. So this is an interesting one that would show us how to get something that's actually sort of meaningful to us, to find where IP addresses are listed in our code or in our history. If we were trying to look back through our command line history and find that we had SSH'd into a particular server, we could use a regular expression search on our command line history and find anywhere that an IP address was listed there. So getting back to Java, here's some specific examples of how to use regular expressions in Java. First, you have to create a pattern. You call to pattern.compile, with a string that contains your regular expression, like the one down here that matches to IP addresses with an optional port. Then we have a matcher, which is specific to a string. So the regular expression itself is not specific to a string and can be used on many different strings to match them, like all of the lines in our command line history. And a matcher is given a specific string and using that compiled pattern P to do the regular expression matching inside of this specific string. And then once you've done that, you can ask whether it matches. That's a Boolean return there, true or false. We can do a find. So matches, by the way, will match only if the entire string matches. A find will say true if some substring of this string matches our regular expression. And then we can get parts of the match and sort of pull it apart using the regular expression and using the groupings. Remember, parentheses create groupings inside of a regular expression. So we could get the subnets and the network and the port number and all of these different things using the groupings. And that's exactly what we do here. We compile a regular expression using the thing that we looked at a moment ago that would match to IP addresses. Matches returns false because I've got this username at before the part that would actually match my regular expression. Find returns true because we're able to find some part of it that matches the regular expression. From the 132 out to the 22 will match our regular expression. So if I ask for group 0, it gives me the whole match, everything that matched to my regular expression. If I ask for group 1, it will give me whatever matched in the first set of parentheses here, the dot and then 1 to 3 numbers. If I asked for group 2, it will give me what matches in the second set of parentheses here, the colon and then 1 or more numbers. So here the colon 22 to indicate port 22. So you can see already that I would be able to pull out meaningful information from this string to be able to see what IP address was connected to, what port it was connecting on, and possibly other information. I could, if I wanted to, write it so that it got the username that was used to connect as well. Another way to use regular expressions in Java is to split strings. The regex.pattern.split method will split the string up into an array of strings according to some separator or delimiter for it. So it's similar to the split method from the string class as well. So we could create a pattern and compile it on a particular regular expression and call split, but actually we can sort of shorthand that by calling s.split with some particular string that will also use a regular expression to match. So here we have a string that's got a port number there, and let's say we define different regular expressions that we want to split on. So for instance, we've got one that's just a colon. It will split anywhere there's a colon. Well, there's only one colon, so it splits it into 2 strings, the IP address and the port inside of an array. If we do a dot, then it will split anywhere there is a dot. However, remember, because dot is a special character in regular expressions that indicates any character, then we have to escape it. And a weird little thing about this is we have to double escape because otherwise the slash itself will try to get eaten by Java, because Java looks for slashes to indicate things like /n, special Java characters. So we have to double the slashes to get it to escape that period there, and we'll have to do that for any escapes that we do inside of our regular expressions. So when we separate on dot, we get the networks, subnetworks, etc. But the port is still attached to the 1006, the last number in my IP address. So instead, I could write a regular expression that says, okay, split where there's a period or where there's a colon. And it will go ahead and do that. It splits all of the network, subnetwork, etc., and the port, and it removes, you'll notice, whatever was the separator too. And then I could also similarly say, just split on anything that's not a number. And in this example, that gives us the same result because the periods are not numbers and the colon is not a number, so it splits the exact same way into this array here. If I say split on 1, then it will cut the 1 out of various pieces. We strangely end up with an empty string at the start because the first character was the separator, so we get an empty string there at the start, and then we get some other weird different splits from it there. I could say split on anything that's not a 1 or more times. And then it's going to cut out anything that's not a 1. It cuts out the 3, 2 and splits there and the period. It cuts out the 7, 7 period, 4 period and gives us just the 1 that's here. And it cuts out everything else after that 1 because they're all not 1. Not the most helpful example, but it may give you some illustrations of ways you could do things to get only the data that mattered to you, like to get all of the numbers out of some document that also contained names. We also implicitly use regular expressions when we use a scanner in Java. The scanner has a delimiter that you can define, and that delimiter by default is set to white space. But you can change the delimiter, and when you do that, you can use a regular expression as your delimiter and indicate what you would like to split on. So for example, here we've done one that is a semicolon or any amount of white space, followed by any amount of white space. So /s gives us spaces, and we have to double escape the slashes there. And then the star says 0 or more of the spaces. So we will split wherever there's a semicolon, and we will split, and we will continue to take any number of spaces that follow it. So for instance, it splits with the semicolon here and leaves us a nothing sort of space. It splits with the semicolon here, but it doesn't eat the space before that's attached to the A. It eats the spaces that are after the semicolon because it's semicolon followed by spaces. And then it would do the same thing after the B, and the same for the semicolons here where we get empty results from each of those. And it does the same thing for D. So the scanner, if you called next over and over again, would produce the following string tokens here. The scanner goes ahead and skips the first one. If we had done split like before on our string or on our data there, we would get an empty one, but the scanner goes ahead and skips the first when it's completely empty and only has the delimiter. And you will notice it eats up all of the white space before B because it's allowed to. It's allowed to take a semicolon and any amount of white space. Not just, it's greedy with it. It takes as much as can fit its expression. It leaves the space after A, as I mentioned, because its rule is not a semicolon with spaces before it. Its rule is semicolon with spaces after it. So it doesn't touch the space that comes before the semicolon. It does create empty tokens here, and we would have empty results that we would print out with this code that's shown here. And then D is just normal. And there's a delimiter after D, but we won't get anything from it. So the scanner uses regular expressions, if you want, as a type of delimiter so that you could split your document on any kind of pattern matching that you wanted to. So overall, regular expressions are a useful tool. They can be used in Java as in many other places. In Java, we use the regex library mostly to create patterns, to do matches, and to find parts of the match results. But we also are implicitly using regular expressions when we set the delimiter for a scanner. We can use regular expressions to split data coming from a scanner up in more useful or interesting ways to us by defining a regular expression as the delimiter there too.